We have learned a very vital part in trigonometry, and that is the aspect of special angles. Okay, and in special angles, we had something like this: an expression for sine 0 degrees, tan 0 degrees, and cos 0 degrees up to 360 degrees. Now we want to use this to draw the sines, draw the graphs of sine theta, cos theta, and tan theta. So to draw the graph, we'll just say wet theta will equals to 0 degrees. Have a table, theta and sine theta, 0 degrees. We will have 90 degrees. We will have 180 degrees, 270 degrees, and 360 degrees. For sine theta, cos theta, let's begin with those two, just to show the basic graphs of trig elements. Now moving on, when theta is equal to 0, sine theta is equal to 0, and cos theta is equal to 1. So we are basically reducing this graph, the table, to just 0, 90 degrees, 180, 270, and 360 degrees. So this will be 0, cos theta is 1. When it is 90 degrees, we have 1 and 0. When it is 180 degrees, this is being changed to 0 and 1, minus 1, 270 degrees, minus 1, 0, 360 degrees, 0, and plus 1. Now we can see the alternating section moving from 0 to 1. Okay, and this is moving from 0 to minus 1 and back to 0. Cos theta will start from 1, goes to 0, down to minus 1, back to 0, and back to positive 1. So let's represent this in a graph. So I have the Cartesian plane, and the values of my x ranges from 0 to 90 degrees, okay, to 180 degrees, to 270 degrees, down to 360 degrees. And the values of my y are just positive 1 and negative 1. So let's begin with y is equals to sine theta. So it's best, let's duplicate this so we don't get it mixed up. We do for cos sine theta, and we also do for cos theta. So let's begin with y is equals to sine theta. At theta is equals to 0, sine theta is equals to 0. So we have a point here. At theta is equals to 90 degrees, we have y sine theta to be equals to what? Positive 1. So this will be here. When theta is equals to 180 degrees, sine theta is equals to 0. So we have the point here. When theta is equals to 270 degrees, sine theta is equals to minus 1. We have the point here. When theta is equals to 360 degrees, we have theta to be equals sine theta to be equals to 0. So with this, we are saying that the graph starts from 0, moves to 90 degrees in a sinusoidal manner, back to 180 degrees, okay. When it gets to 180, it moves down to 0, back to 360 degrees. So in conclusion, we can just simply say that sine theta has the format of 0 to 1 to minus 1 to 0, 0 to 1 to 0 to minus 1, back to 0. This is y is equals to what? Sine theta. Now let's do y is equals to cos theta. Y is equals to cos theta. So we are saying that when theta is equals to 0 degrees, our cos theta is equals to 1. So it is starting from 1, positive 1. When theta is equals to 90 degrees, we can see it here. Our cos theta is equals to what? 0. This should be 0. So it will go back to 0. when theta is equals to 180 degrees, our sine cos theta is -1. So we can see that it comes to -1. When theta is equals to 270 degrees, okay, our sine cos theta is equals to 0. And when theta is equals to 360 degrees, our cos theta is +1. So from here it goes back to 0 and back to +1. So drawing a graph now for cos theta, we'll have it starting from 0, starting from 1 rather, comes to 0. When it gets to 0, it turns back in a sinusoidal wave curve, goes back to 0 and back to -1. So we can say that the graph of cos theta starts from 1, goes to 0 and back to -1 in a sinusoidal manner. So these are the basic templates of, okay, this is y is equals to cos theta. These are the basic templates of graphs. So we have y is equals to sine theta. Let's give meaning to the graphs. And y is equals to cos theta. For sine theta, it starts from 0, goes to 1. Once it gets to 1, it goes back to 0 and back to down to -1 to 0. However, for cos theta, the graph starts from -1, goes back to 0, goes to -1, and goes back to 1. Now we'll observe that the amplitude is 1 for these two graphs. Amplitude is 1. Amplitude is 1 -1. So this is the basic representation of graphs of y is equals to 0, y is equals to sine theta, and y is equals to tan theta. Now, if we take a look now at tan theta, let's look at tan theta. Y is equals to tan theta. So let's draw a graph. It looks totally different from this. Let's draw the table. We have theta at 0 degrees, 90 degrees, theta at 180 degrees, at 270 degrees, and 360 degrees. What then is tan theta? Let's begin. When theta is equals to 0, what is tan theta? Theta is equals to 0, tan theta is equals to 0. Theta is equals to 0, tan theta is equals to 0. When theta is equals to 90, okay, tan theta is equals to what? Undefined, infinite, undefined. When theta is equals to 180, you can say that our tan theta is also 0. When theta is 270 degrees, our tan theta is what? When theta is 270, our tan theta is infinity. When theta is 360 degrees, we can see now that our tan theta is also equals to what? 0. Now, you might not be able to get the full image of what is being depicted here, but then let me explain it with a template of tan theta. So we have y axis, and then we also have x axis, or let's say theta axis. So tan theta is such that it has y, infinite values of y at 90 degrees, as we can see, infinite values of y at also 270 degrees. However, it has values of zeros at 0 degrees, values of zeros at 180 degrees, let's call this 180 degrees, and values of zeros at 360 degrees. Now, to fully understand the graph, we have to get the full length. That means we will know what is 0 degrees, maybe 10 degrees, 20 degrees, and the likes. but then we just want to explain the image of the graph. So once we have this, it goes from 0, it doesn't touch the asymptote, and continues in that order. Similarly for this, it starts here, not touching it, goes to 0 and follow this order, not touching the graph, and it continues in that order. So when it gets here, it touches y is equals to 0, x is equals to 0, and goes. So this is the template of y is equals to tan theta. So now we have an understanding of the graphs of trig, and we can apply this in the future when we are asked to draw the graph of a trigonometric function. Let's say if we are asked to draw the graph of y is equals to 2 sine theta, or let's say the graph of y is equals to 2 cos theta, maybe plus 3. So all we just have to do is just to draw a table of theta, okay, ranging from a range of values, maybe 0 to 90 or 0 to 180. So we can have 0 degrees, 90 degrees, or in terms of 30s, 0 degrees, 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, and you can stop at 180 degrees. Then you evaluate the value of y. So all you just have to do is to just substitute this into this. All right, so let's take that as an example and let's do it together. So 0 degrees. So we will just have to evaluate y. So when we have y is equals to 2 cos theta plus 3, when theta is equals to 0 degrees, 0 degrees, we have 2 into cos into 0 plus 3. So cos 0, as we have found out, is equals to 1. So this 2 into 1 plus 3, and this will be 2 plus 3, which is 5. So we have y is equals to 5. If we do the same thing here, and we can just skip this whole process and use our calculator directly. So we say that's 2 cos 30, and the answer is being added to 3, and we will have 4.732. Do the same thing for angle 60. We'll have the answer to give us 490, 3, 120 will give us 2. We can see a decrease in format, 150. We have 1.27, 180 now. We'll have 1. So we can see it was being decreased from 5 to 1. So it is showing that the graph is starting from y is equals to 5 and then stopping at y is equals to 1. So if you plot a graph here, I don't have the graph tools, I will have explained it to you on how to plot trigonometric graphs. So you see that it will move from y is equals to 5, okay, down to y is equals to 1, and then it will go back up again to y is equals to 5, and the cycle continues. So that's all on graph. What I just need us to understand is when we say y is equals to sine theta, we are saying that the graph looks like this. When we say y is equals to cos theta, we'll understand that the graph looks like this. And when we say y is equals to tan theta, we are saying that the graph looks like this. Okay.